Hello, my name is John Quinn, and in this session I'm going to talk about high availability and disaster recovery within ArcGIS Enterprise. Now there are two major risks that we want to focus on within this presentation. Data loss, or your recovery point objective, otherwise known as an RPO, and downtime, your recovery time objective, or RTO. These can disrupt business operations, affect customer trust, and cost your organization valuable time and money. For example, can your company tolerate a day's worth of data loss, or a day's worth of systems being unavailable? In this presentation, we want to give you some tools and techniques to avoid these particular risks. There are a number of different approaches to avoid data loss and downtime. The first is creating backups. So when you create a backup, you take a snapshot of the environment and data at a point in time. You can store that backup in a secure location and apply the backup in the event that there's a failure. The next is high availability. High availability ensures that there's no single points of failure within a data center. So there's multiple machines with the same role or function, and if one goes down, another can continue performing the same function. Then there's geographic redundancy. And in this case, you have separate data centers. They're configured identical, so they're mirrors of each other, and all requests are going to a primary data center. If the primary data center goes down or has a significant issue or outage, then you can flip over to your standby data center. Now, what's important to note is that these different approaches are not exclusive of each other. You don't use one versus another. They're built upon each other to achieve a complete disaster recovery plan. At minimum, an organization should be consistently backing up their data and configurations on a schedule. On the other end of the spectrum, an organization investing in geographic redundancy will likely be using high availability within a data center. So the investment cost typically steers an organization towards one approach or another. They have to think about how much money it takes to invest in the hardware or software associated with the plan they want to implement. You have to have the people, staff with the correct knowledge to make sure that they can execute the plan effectively. And you need to have the time in order to practice and perfect a disaster recovery plan. First approach we want to get into a little bit more detail about is backing up and restoring a deployment. So backups are the easiest way to avoid data loss and downtime. They can be formed hot, meaning there's no downtime on the system when the backup is getting created, and it's largely underappreciated. We may take for granted that our phones have automatic backups. If you get a new phone or when you break your phone, you have to get a new one. You can restore contacts, restore apps, etc. And there's a number of different ways that you can create backups. You can create a snapshot of a virtual machine. You can create a backup of a file server. And there's software backups. So the ability to create backups of, let's say, an enterprise database, Oracle, SQL Server, Postgres, they all have backup utilities. And actually, ArcGIS Enterprise also has the ability to create backups. So in this presentation, we're going to be focusing on the WebGIS DR tool as a way to create enterprise backups. The WebGIS DR tool was introduced at version 10.4 and is included with the installation of Portal for ArcGIS. And what it does is it backs up a full ArcGIS Enterprise deployment at a specific point in time. This means it backs up all the settings and configuration data within Portal, Server, and the data store. It'll back up all of the content within the portal, all the services that are published to any federated server, including the hosting server, and also all of the data within the relational data store, and optionally any tile cache data store. The time to create backups is going to be dependent on the size of the deployment. It could range from a half an hour to an hour or more. And again, it does require Portal for ArcGIS, so it won't run with a standalone ArcGIS Server site. As important as it is to talk about what the tool does back up, it's equally important to talk about what the tool doesn't back up. The DR tool won't back up any data within an enterprise geodatabase or any file-based data. Your traditional map cache tiles due to the large size of them, the data within the spatiotemporal data store, or running services within a GeoEvent server. When you're ready to create a backup of an ArcGIS Enterprise deployment, what are the steps that you need to go through? Well, first, you have to populate the properties file. Provide what portal URL that you want to back up, credentials, where you want to store the backup, whether you want to include the scene tiles, and ideally you would automate it. So you would create a Windows task within the task scheduler, or using a cron job to automatically create backups for you at a set interval. A properties file included with the install of portal will determine how the DR tool will interact with the deployment. Now there's some questions that you have to ask yourself when you're populating the properties file. First, where is the content? Is it on the file system? Is it a bucket in S3 or a container in Azure? Where do you want your backup stored? Do you want it to be stored on the file system, in a bucket in S3, or a container in Azure? So these properties are going to govern where the backup places files and what properties you have to populate within the properties file. There's a set of minimum parameters that have to be populated in order to run the DR tool. First, you have to populate the portal admin URL. This is the URL to connect to the portal that you want to back up, or the enterprise you want to back up. Credentials for any administrator within the deployment, the type of backup you want to run, where to stage the backups, and finally, where the backups should be stored, whether it's on the file system or the cloud. When you're using the DR tool to create a backup, all components are backed up concurrently, meaning as soon as you run the DR tool, it starts the backup for portal, server, and data store, and any other federated server at the same exact time. Now there's no downtime while exporting, but there is going to be some increased CPU usage on the machine as the backups are getting created. Now the syntax to create a backup is to use the -e or -- export argument to export, and -f or -- file to provide the path to the WebGIS DR Properties file that you've populated. When you're ready to run the restore is going to run sequentially. First it'll restore the ArcGIS data store, next it'll restore server, and then finally it'll restore portal. There is going to be downtime while restoring, so you won't be able to access the deployment until the restore is complete. The syntax to restore a backup is very similar to creating a backup. Instead of the export argument, it's going to be import or -i. Now I want to highlight some changes we made at 10.9 related to the DR tool that caused some issues within Portal. Prior to 10.9, so 10.8.1 and earlier, there were two different modes, a full backup and incremental backup. We'll talk more about those when we talk about geographic redundancy. But when you run a full backup, there was a limit on transaction logs that was removed. If you didn't run another full backup for a while, those transaction logs could fill up your hard drive. The only solution was to run the DR tool again. Now at 10.9 we've introduced another mode called backup, and this is to complement the full and incremental modes that are already there. The backup mode does not remove the limit on transaction logs. This would be used in a situation where you're not using geographic redundancy, where you're restoring, you're taking advantage of incremental backups, and this would be used if you're simply creating a backup to be used to restore to the environment in the event that there's a failure. Creating a backup with the backup mode does not remove the limit on transaction logs, which will preserve the space on the hard drive space on the portal machine. A second improvement we made at 10.9 is regarding the time it takes to create backups. Something that really prohibited the use of the DR tool within some organizations is the amount of time it took to fully create the backup. This was create all the backups for portal, server, and data store and package those into a single backup file. Well, at 10.9 we made some significant improvements to how long it's going to take to create backups. So for example, at 10.8.1, with 220 gigabytes of data across portal, server, and data store, creating a backup would take 43 hours and 40 minutes. Now this was packaging the backup staging and packaging the backup to a share. Right? So there's network latency involved. There's the the throughput of reading and writing to that share. But again, it took 43 hours and 40 minutes. 37 hours was simply spent packaging. Now that environment just did an in-place upgrade to 10.9, so everything was identical except the version. And creating a backup at 10.9 only took 3 hours and 29 minutes, where an hour and 15 minutes was spent packaging. So this was a significant improvement, and there are some things that we want to work on for another later version after 10.9. But again, wanted to highlight that we did hear some feedback about the performance of the DR tool, and we did want to make some improvements in that regard. Next, I'd like to talk about high availability. First, we'll take a step back and talk about what high availability means. We'll transition into talking about high availability within ArcGIS Enterprise, specifically getting down into each component and how it is highly available, as well as talking about upgrades. And we'll talk about other factors relevant to high availability. First, it's important to talk about what high availability is. Well, by definition, it's a system or component that is continuously operational for a desirable set of time. And it's going to be measured relative to being 100% operational, or maintaining a service level agreement, or SLA. And it's often measured in the number of nines. So are you 2 nines, 3 nines, 4 nines of availability? And naturally, the more nines you have, the more costly it is. The amount of money and time and effort to support a deployment that is available 99% of the time is far less expensive than than a deployment that has to be available 99.99% of the time, or to support 4 nines of availability. In general, though, it means that there's no single points of failure throughout the deployment. So even if one component goes down, you shouldn't see any issues with accessing the resources available by that deployment. Now, the availability of a system is really going to be dependent on the availability of all components, processes, and people. It's not only that you have enough hardware or software to support HA, but you have practices in place, you have people to support the deployment. Everything has to line up for you to have a highly available system. So ArcGIS Enterprise supports high availability out of the box for Portal for ArcGIS, ArcGIS Server, and ArcGIS Data Store. The web adapter is also involved in supporting high availability, which we'll talk about within this session. First, I want to talk about how to get requests into the deployment. There's 2 different options. The first is the ArcGIS web adapter, and the second is a third-party load balancer. The web adapter is provided by Esri, and it supports web tier authentication. So if you are interested in taking advantage of again, integrated Windows authentication or LDAP, then you'll need to use the web adapter somewhere within your deployment. The web adapter can detect when machines are joined or unregistered from the site, and automatically update based on the health of the machines so that it doesn't send requests to machines that are down. A third-party load balancer is not provided by Esri, and it's a commercial load balancer like F5, Big IP, Barracuda, HA Proxy, or Nginx. And these, normally they're already fault tolerant. Now the challenge with them is that they can't really detect when the machines change within the site. For example, you're auto-scaling and you add a server machine to the site. Well, you need to make sure that the load balancer is aware of that update. If you register a new portal machine or unregister that machine from the portal site, again, you need to make sure that the load balancer is aware of that change. Now I'd like to focus more specifically on ArcGIS Enterprise, and first we're going to look at Portal for ArcGIS. A highly available portal operates with 2 portal machines, and it's both active, but also active-passive. It's active at the web server, meaning that your load balancer or the web adapter can send requests to both machines at the same time. However, it is active-passive at the database level, which is part of the deployment of Portal. There is going to be a primary database, which does correspond to being a primary portal. And there's automatic replication that's happening between primary and standby. Now, the role of the portal machines is going to determine what happens when that machine fails or goes offline. If the standby machine becomes unavailable, there's going to be no interruption to a user's experience working with the deployment. However, if the primary becomes unavailable, there may be an outage while the standby is promoted to primary. After the original primary comes back online, it's automatically going to be joined as standby. So now I'd like to cover some of the different deployment patterns for a highly available portal. The first is that you would just have a highly available portal with a load balancer. Now, this could be a simpler and more straightforward approach because less software to install, and the network path is a little bit more straightforward. It's just a load balancer going, forwarding traffic to the portal machines. However, this approach does not support web tier authentication. The next pattern that you can use is with a load balancer and web adapters. The load balancer would forward traffic to the web adapters, which in turn would send the traffic onto the portal machines. This does support web tier authentication, but it's slightly more complex in that there's more software to install and configure, and there are some required steps that have to be made on the web adapter machine within the application pool to support this type of pattern. An important concept with a highly available portal is to make sure that the portal machine is available to take requests. And this is done through the health check available within Portal for ArcGIS. Most, if not all, load balancers support a health check function, something that will check the health of the backend machines that it's going to send requests to. So this is accessed through portal admin/health check, available directly through the web adapter or through 7443. And it's important that you configure an HTTP health check, because it's not enough to simply say, can the machine be reached, right? Because if the machine is accessible and you're just, the health check is just asking, well, can I reach the machine that Portal is installed on? That's not really going to give you the full picture of whether the machine can take requests or not. You want to make sure that the machine is accessible, the Portal for ArcGIS service is running, and you're using the software-based approach to ask Portal, are you healthy and can you take requests? When you're ready to upgrade a highly available portal, the thing to keep in mind is that even though you do have two machines, it's still one portal. So an upgrade is going to introduce downtime. Now, for that reason, it's important to plan and practice your upgrade, and also take advantage of read-only mode in the event that you do have another deployment that you can use to upgrade. It's important that you make a backup. In the event that something goes wrong, you'll have a backup to restore to. And there's no need to know the roles of machines when upgrading to 10.7 or later. This means that you can use similar steps as a standalone portal to upgrade it from your current version into the next version.
So I want to end on some key considerations for a highly available portal. First, it operates as a two-machine cluster, so there's a primary and a standby. And it's important to have a highly available load balancer. This is going to direct traffic to the two portal machines. If you're going to use web tier authentication, make sure you have multiple web adapters to support redundancy at the web tier. Make sure you're taking advantage of the health check URL. This ensures that your load balancer is sending requests to machines that are healthy. The content store stores all the data that's created by users, so make sure that this is highly available and you're taking backups. When you want to upgrade, the downtime and steps are similar to a standalone portal. And finally, make sure that all portal machines are in the same data center. Now I'd like to talk about the second software component, which is ArcGIS Server. Multi-machine ArcGIS server sites, they've been around for quite some time now. And when you have a multi-machine site, there's no real concept of roles. So there's no primary server or standby. There's no concept of that in a multi-machine server site. Now that being said, there's no interruption when any of the machines goes down, because there's no failover, there's no promotion that has to take place. The config store and server directories need to be accessible to all machines so that they can keep track of which machines are part of the site and the health of the machines. Now, similar to Portal for ArcGIS, there's two different deployment patterns that you can take advantage of. The first is you're going to use a third-party load balancer. The load balancer is going to balance traffic between the machines that participate in the server site. And the thing to keep in mind is that this deployment pattern does not support web tier authentication. There's also less software requirements. You don't need to install and configure the web adapters in this deployment pattern. The second pattern would be one that would take advantage of web adapters. You would still have a load balancer that forwards traffic to the web adapters that are configured with the multi-machine server site. And the web adapters would forward traffic to each server machine. The web adapters are aware of the health of the server machines, are able to send traffic only to healthy ones, and can keep track of which machines are participating or removed from the site. This pattern does support web tier authentication, but it would require more software, the requirement to install the web adapters on a running web server. Similar to Portal, ArcGIS Server has a health check URL. This is accessible through the web adapter or through the machine directly through REST info health check. Now this determines whether the machine can accept and respond to requests. It does not check whether specific services are running. When you're ready to upgrade a multi-machine server site, the upgrade is done sequentially on each machine. For example, you'll install the software on each machine. For example, you have a 4-machine multi-machine site, and you'll install the software on all machines, and then you'll continue the upgrade on each machine through Manager or the Admin API. Now here's some key considerations to make for a highly available ArcGIS server site. First, make sure that the shared config store and directories are on a highly available share. Next, make sure you're determining the health of the machine through the health check API within your load balancer. When you want to upgrade, install the software first on every single machine within the site, and then sequentially go ahead and continue the upgrade on each machine. Similar to Portal, all ArcGIS server machines must be in the same data center. Now, to get a base deployment or to configure a base deployment, you need to federate your portal and server. Now when you do this, there's a number of important URLs that you need to pay attention to. First, you have the portal URL that will be used for clients to connect with. Things like Survey123, Collector, any of those mobile applications or any desktop application are going to use the portal URL to connect to the deployment. Then you have the services URL. This is the URL that clients will use to consume any of the services within the deployment. Both of these are going to go through a standard port of 443. Then you have some internal URLs. These URLs are facilitating the communication between portal and server and portal. First, the private portal URL allows the server, any federated server, to talk to the portal site. And on the other hand, you have the administration URL. This allows the portal to talk to any federated server. So at the top, again, you have this client communication over 443, and then you have the administrative communication that's happening internally. In order to configure the portal and the deployment to use the URL that you're interested in using, you will do that through the properties, so system properties for Portal. In order to ensure the federation uses the correct URLs, you'll configure the services URL and administration URL appropriate for the traffic pattern that you need to configure. Now, considering you have all this communication happening within your deployment, you need to make sure that all the URLs that you would configure the deployment with are highly available. For example, they all go through a load balancer. That load balancer is being used, is configured to check the health of the machine, the backend machines it's sending requests to. This would happen for the portal URL, the private portal URL, the services URL, and the server administrative URL. All these URLs need to go through a URL or a component like a load balancer that's able to detect when machines are down and only send requests to healthy machines. So we've talked about Portal for ArcGIS and ArcGIS Server, and now I'd like to talk about ArcGIS Data Store. When you have a highly available relational ArcGIS data store, it's going to operate in a primary standby fashion. So the primary is going to be replicated to the standby automatically, and the ArcGIS server site, likely a multi-machine site, will be communicating directly with the primary data store. If the primary data store goes down, then the standby will be promoted to primary, and it's going to notify the ArcGIS server site that there is a new primary, so that the ArcGIS server site can now communicate with the new primary machine. Starting at 10.8, there are two different modes that a highly available tile cache data store can operate in. The first is a standard primary and standby fashion, again similar to the relational ArcGIS data store. The primary is replicating data to standby. The ArcGIS server site knows that which one is the primary. If it goes down, then the standby is going to be promoted. The other pattern is a clustered pattern. So each are cluster members. They all have the data that each needs to serve out any of the data within the tile cache data store. And if one of those goes down, there's no promotion. There's no need to promote to any roles within the ArcGIS data store cluster. The ArcGIS server site will know only to communicate with the healthy cluster members. Now, the failure scenarios for the ArcGIS data store are slightly different than Portal. For Portal, if you stop the service on the primary, then standby will promote itself. However, for the ArcGIS data store, that's not the case. Instead, there are internal checks that determine different failure scenarios. For example, the computer crashes. It gets unplugged from the network, or it loses network connectivity. Or there's disk corruption. It does not fail over immediately if the service is stopped. So that's an important thing to keep note of if you're going to be testing failover for the ArcGIS data store. When you're ready to upgrade a highly available ArcGIS data store, the process is similar to Portal for ArcGIS. You would run the setups on both machines to upgrade the software to the latest version. And then you don't need to take any note of roles. This is new at 10.7. You would simply configure the ArcGIS data store again to upgrade both relational and tile cache. Upgrading a highly available ArcGIS Enterprise deployment is similar to upgrading a standalone enterprise deployment. First, you would upgrade your portal, then you'll upgrade your ArcGIS server site, and then you'll upgrade the ArcGIS data store. So when you're configuring a highly available deployment, there is a couple of times, for the ArcGIS server or portal, I mentioned that you need to have a shared directory to store site data and configuration files. Well, if you're in a cloud environment, you can take advantage of cloud storage options for highly available deployments. This is for storing site data and configurations, again the portal content store and the ArcGIS server config store. You can store backups in cloud storage, for example the ArcGIS spatial temporal big data store backups, as well as backups from the WebGIS DR tool. And you can also store content from other workflows in cloud storage, such as map service cache tiles, geoanalytics data input, and the output for raster analytics. So native cloud storage is a great option because it's by default highly available, but also highly scalable. And as I said in the beginning of this session, it's not only that you have all the software that you need to be HA. Well, there's a lot of other parts of the deployment and parts of your system that also need to be highly available. For example, is your data highly available? Do you have an enterprise geodatabase that is replicating data to either hot or warm standby? Is your file-based data in a location that can handle failover and failures? Do you have enough web servers and do you have a highly available load balancer? Can your hardware support the traffic that occurs between the different machines when they're running the software? And do you have the correct people and processes, or the knowledgeable people and processes in place to make sure that you can maintain an HA architecture? Again, it's not just software. There's a lot of different aspects to making sure that your architecture is highly available. Now, a lot of times, an IT staff may not be a part of the GIS team, which makes things definitely a bit challenging. But ultimately, it's really important that you make sure that policies and procedures are highly disciplined. You're planning how patches and upgrades are installed. The process of doing so is documented clearly. You're doing the proper testing in a QA environment. And the staff is all knowledgeable about the requirements for being highly available and the procedures to maintaining such an environment. And again, we want to emphasize that being highly available is a spectrum. It's not a switch. It's not whether your system and your architecture is highly available or not. It's how far along the spectrum are you highly available. As your system requirement and your SLA, so your service level agreement, warrants more and more availability and more tolerance to failures, it's going to cost more and more. For example, to withstand days worth of downtime, that doesn't really cost that much. Instead, to withstand an hour's or a few minutes, it may interrupt your workday. The cost is greater than supporting a day's worth of downtime. If you want to support a momentary interruption, you're down for minutes or seconds. Again, that's just an increasing cost. And this is a lot of this kind of rests on ultimately maintaining business continuity and being able to fulfill your mission critical applications. For example, if you are emergency response, you need to be up all the time. You need to be able to withstand outages. You need to be able to recover quickly if there's an issue within your deployment. On the other hand, if you have if your organization has 4 or 5 GIS people, and they're the ones accessing your deployment, maybe HA isn't the best strategy. So understanding your business requirements is going to be really important in determining whether high availability is right for you. And finally, I'd like to talk about disaster recovery taking advantage of geographic redundancy. First, I want to go over what is geographic redundancy. I'll talk about how you can achieve geographic redundancy using the WebGIS DR tool, and then what are the steps involved in using this type of disaster recovery plan. As the name implies, geographic redundancy involves geographically separate data centers. For example, you could have one on the East Coast and another on the West Coast. One is active and one is passive, so all the users that are connecting to the deployment are connecting to the primary data center. In the event that the primary goes down due to some catastrophic event, you're able to switch over to the standby data center to continue normal operations. Now, what this requires is that you have duplicated configurations and data between the two data centers. In most situations, components within data centers are also going to be highly available. So not only can you fail over within a data center, so you can fail over components within a data center, you can also fail over whole data centers if necessary. Now there shouldn't be any loss of functionality, capabilities, or data. So again, making sure that each data center is a mirror of each other is going to be important. The WebGIS DR tool can be used to move snapshots of data between primary and standby. Now this is kind of the more complex disaster recovery option, given the requirements for duplication, the number of machines required, having separate data centers, and the coordination to take backups and restore them. Now I'd like to go through a theoretical situation involving geographic redundancy. First, I have my primary data center and my standby data center. My primary is on the East Coast and my standby is on the West Coast. My traffic manager is directing traffic to the East Coast data center. Both environments are configured with the same public URLs. So the public portal URL and the services URL to reach the server site and the portal are both the same. What also needs to be the same are any paths to any reference data within services. I'll go into more detail about specific requirements for duplication in a second. So on a scheduled basis, I'm taking a backup from East Coast data center, shipping it over to the West Coast data center, and then restoring it. In the event that my East Coast data center goes down, so my primary environment goes down, I can flip over the traffic manager to send traffic to the standby data center. Once I resolve the problem that took down the East Coast data center, I can flip back over to the East Coast and then continue the replication process to continually move data from the East Coast to the West Coast. Now recall in the initial session section of this involving the WebGIS DR tool and the high availability section of this, I mentioned that we do support cloud storage for both the portal content, the config store, and the backups. So when you have a cloud deployment using native cloud storage for the data and configuration files, you could also use it to store the backups. In this particular case, I've got the East Coast region. I'm creating a backup, and I'm storing the backup in, let's say, a central region. And then from there, the West Coast region pulls down the backup from the central region and then restores it. This is all using, let's say, native cloud storage for portal content as well as a config store for ArcGIS Server. So how do you achieve geographic redundancy? Well, here are the high-level steps that you would have to go through. First, you would need to duplicate the deployment between primary and standby data centers. This means that you would need to install the software, you would need to configure it, validate and make sure that they both work in each environment. Next, you would create snapshots in the primary data center. This is using the WebGIS DR tool. And then you'll move those over to the standby data center. Next, you'll apply the snapshots to the standby data center. And finally, there's not so much as a step as much as it is an ongoing practice, but you'll monitor both data centers to know when you either need to fail over to the standby or to address any issues that may come up in either data center. Now I'm going to go through each of these individual steps in a little bit more detail. And the first step would be duplication, making sure that your primary and standby data center are essentially mirrors of each other. Now it's a recommendation that the number of machines should be the same between primary and data center. Now the reason for this is that there shouldn't really be any drop in redundancy, performance, functionality if you do have to switch over to your standby. Now, many organizations may not want to invest the same amount of hardware for a standby data center, so you can have an environment with a reduced capacity to restore to. It's important that you have identical URLs between data centers. Now these are just the public-facing URLs, the public portal URL and the services URL. The internal URLs, for example, the private portal URL and the admin URL, they can be different. We'll go into that in a bit more detail in a second. And next, you have to have identical paths to data. This is the data that would exist within a file geodatabase or an enterprise geodatabase, not the ArcGIS data store. So anything that is referenced, the connection strings and the paths have to be identical between your primary and standby data centers. Now this step is potentially a little bit complicated. You need to make sure that, well, one, you have a second data center that you can use. It involves spinning up the correct number of machines, provisioning the machines to install the software with, actually installing and preparing the components, so installing the software, federating, setting up the base deployment, and then thinking about how traffic is going to get routed. You want to make sure that if the standby is going to access, a URL, you want to make sure that URL doesn't route traffic to the primary data center. So using, the Esri host file, using DNS, a split DNS approach, separate load balancers to handle the internal traffic within each data center are going to be some of the important concepts to take advantage of. Throughout each release, we've been reducing the requirements to run the tool in order to restore to the same machine or different machines. For example, when the tool was first introduced at 10.4 and 10.4.1, everything had to be the same. Public-facing and internal URLs, by reference data stores, the server site directory paths, machine names, security information, all of this had to be exactly the same as where you wanted to restore the backup. Now obviously that doesn't work, and a lot of organizations are not going to be able to mimic every single part of the deployment. So release by release, we slowly remove some of the requirements that were in place at 10.4 and 10.4.1. For example, at 10.5 you can have different machine names as well as different internal URLs. So the private portal URL and the admin URL, they could be the same between where you take a backup and where you restore the backup. Starting at 10.6.1, there are some further reduced requirements. For example, the server site directory paths and security information can be different. For example, in your primary data center, you have a specific domain controller IP address, but that may not exist in your standby. So we want to make sure that we continue to honor the security information set in standby, so that that's one of the pieces of an architecture that we would want to essentially cache during a restore. Now once you've duplicated your deployment, so you have a primary and standby data center, the software is configured, you can begin taking snapshots. Now there's two different types of snapshots, a full snapshot and an incremental snapshot. So the full snapshot is similar to a backup that you would create for backing up and restoring a backup. It creates a snapshot of all the data within ArcGIS Enterprise. Now this is done hot, so there's no downtime that's incurred by taking a backup. And internally, it's going to define a base time that's going to be used for an incremental snapshot. So an incremental snapshot is a snapshot of all the data that has been modified, created, and references to what's been deleted since the last full backup. Now this is designed to decrease the time it takes to synchronize content, services, and data between your primary and standby data centers. Much like taking a backup and holding on to it for you to be able to restore it if there's an outage. The time it takes to create and apply the snapshots is really just going to be dependent on the size of the deployment and the frequency that data is created and modified. So Windows Task Scheduler or a cron job can be used to automatically create and apply the backups. So incremental backups are backups of all the data that has been added, modified, and again references to data that has been deleted since the last full snapshot. So some database administrators may consider this more of a cumulative backup than an incremental backup. And the reason for this is, again, it's always since the last full backup. So say you create a full backup on Sunday, every day you're creating an incremental backup. So as the week progresses, again, you're only capturing, each incremental backup always captures all the data that has been modified or created since the last full backup. And now as you can see, as you go, you progress through the week, the size of the incremental backup can get significantly large. So now your full backup will again reset the size of the incremental backups. So it's important that you think about how much content you're creating on a daily basis, and monitor the size of the incremental backups to make sure that as you progress through the week, it's still feasible for you to create incremental backups versus another full backup. So as you're going through this automated process to take backups and restore them, what's equally important is making sure that you're monitoring each deployment so that you know things are healthy, things are working as they should. For example, on the primary deployment, you're making sure that backups are actually getting created successfully. When those backups are restored to your standby, you're making sure that once the backup is restored, that everything is healthy. You don't really want to deal with an issue in your standby data center when you need to fail over. You want to make sure that you're proactive about addressing those problems. There's a number of different things that you can do to validate whether the backup is restored correctly and the site is healthy. You can check the index within Portal. You can validate federated servers, including the hosting server. You can validate all the registered data stores using server admin. And you can even check important services or applications. Run a query request against a service that is used more often. Make sure that an application that your organization is dependent on is accessible after the restore. When you're ready to fail over a data center, it's important that you're ready to fail over. You're keeping track of the components that are failing within your active data center. Make sure that they aren't in a recoverable state, or that that everything is ready to fail over to your second data center. So you can use things like ArcGIS Monitor is going to be a great utility to take advantage of to make sure that you're monitoring the deployment, making sure to identify when issues come up, or any homegrown monitoring utilities that you have within your organization. So say you are taking advantage of geographic redundancy. You have a primary and standby data centers, you're replicating data, but your primary data center goes down. Well, when you flip over to standby, content can still be created in your standby data center. Now you either need to figure out how to move that data to your primary once it's back up and running, or lose it. At 10.8, we've introduced this concept of read-only mode. What read-only mode does is it freezes the ability to create content within an ArcGIS Enterprise deployment. So it really just freezes the ability to modify anything within the ArcGIS Enterprise deployment. For example, it restricts operations that would modify site configurations, that would be able to edit groups, create content, modify content, delete content. Now everything is still accessible. Organizations or users within the organization can still access the deployment. They can still read all of the data, so they can still consume all the data, access the applications and maps, make query requests against services, but nothing can be created, nothing can be modified or deleted. Now access notices and banners can be used to notify users that the enterprise is read-only. You want to make sure you advertise that state so that a user knows that it is in a degraded state. But this is really a great way that you can make sure that you don't have to worry about how to get content from your standby data center back to your primary when you fix your primary data center. As soon as you flip over to your standby data center, you can place it into read-only mode. Again, this makes sure that there's no content that can be created, no content that can be edited or deleted. You'll fix your primary data center. You'll flip back over, turn your standby into read and write, and then begin replicating content from your primary data center to your standby data center. So here's some major takeaway points for geographic redundancy. First, it's important to understand the requirements of being geographically redundant as a disaster recovery option. It's much easier said than done. It's really important that you have the practices and people and the knowledge in place to be able to implement this type of plan. For example, it's important that you have an understanding of how to replicate file servers, databases, and geodatabases to make sure that they're accessible in your standby data center. it's critical to have a familiarity with ArcGIS Enterprise, so you understand all the different components and the relationships between each other. It's important to have familiarity with monitoring tools. You need to be able to detect when when components fail within a data center, be able to proactively address those problems rather than figure out that it's been down for a number of times and you have to go back and scour through logs to figure out what went wrong, rather than immediately being able to act upon the problem. It's really important that you run through drills for DR, for disaster recovery and geographic redundancy. You really want to eliminate as many unknowns as possible if you do have to fail over. Practicing will make sure that you identify areas that have to be improved within your DR plan. Take advantage of the DR tool to move the data between your primary and standby data centers. Understand how much content is created throughout a week, and build your schedule dependent on that. If you are at 10.8 and you have a concern about how to manage data differences when you have to fail over to a different data center, consider using read-only mode. And again, geographic redundancy is really a complex disaster recovery option. There's a lot of moving parts. There's a lot of things that you'll need to consider. So hopefully, this presentation will give you an idea of what's involved when setting up that type of disaster recovery plan. Now, ultimately, the decision to take advantage of an on-premises deployment of ArcGIS Enterprise or software as a service like ArcGIS Online is up to you. There's obviously a lot of benefits to different benefits to either option. But looking at ArcGIS Online, there are a number of benefits relevant to the discussion that we've had today. For example, guaranteed uptime, and for that uptime, kind of no cost for the actual infrastructure, as well as any built-in health checks that are available through status.arcgis.com. So looking at all the options on the table, you'll be able to make an educated decision about what best fits you and your organization. Thank you.